This is a homework 7th 8th question, and in the 8th question we get a lot of conditions. First, we know that the number n from the t1 and t2 of points ti in the interval t1 and t2, and it's a Poisson random variable with parameter lambda t, and also we get its equations. However, we know that the Poisson equation is related with the t, and according to the attribute of Poisson process, its expansion equal to lambda. And however, in this question, in a specific time, interval, xt is the parameters lambda t is random variable. So which means that the xt should have relationship with t. So in that condition, the expansion of the t should equals to lambda t. This is a basic Poisson process, I think. And in the second question, first, how to solve it? First, we just consume that t1 equals to t2, and in that conditions we can also use the theory from the last lectures, from the lectures we have learned, and we can easily get the square of xt's expansion is equal to lambda t plus lambda multiply t square. This result we'll use in question 9, and also since we can use some tricks to to assume that two intervals. First, the first interval is from 0 to t1, and the second interval is from t1 to t2, which in condition of t2 is larger than t1. This is the condition. Also, this is the situation. Also, we can assume that t1 larger than t2, and this intervals we also can inverse it and get its own. So let me continue what I just said. Such xt1 is independent with xt2 minus xt1, since this is we get from in the questions condition 2. If the intervals t1 and t2 and t3 to t4 are non-overlapping, then the random variable nt1, t2, and nt3, t4 are independent. This comes from this theory, and so we can how to say, we can just transfer the auto relationship. We just change the xt to the xt2 minus xt1, and we can get the result is lambda t1 multiply lambda multiply t2 minus t1, and in that condition, finally we can get we can also under xt1 multiply xt2, which is equal to xt1 multiply xt1 plus xt1 minus xt1. So put this into the above equations, we can finally get the auto relationship t1 and t2 is equal to lambda multiply t1 plus lambda t1 square multiply lambda t1 lambda t2 minus T1, and this is a normal condition. So which means that if we assume T1 larger than T2, in that conditions, the last part should be changing into T1 minus T2 because T1 is larger than T2. So we can finally get the result of the autocorrelation is different from the different T1's value and T2, and which we need only to assume T1 larger than T2 or T2 larger than T1, and the result should be changed, but it has a normal equations. That's the question 8. Thanks.